It's a really easy question.
I think what we're talking about is what's at the very edge.
Hello and welcome to the Edge Tech Podcast, where technology meets the edge of innovation. I'm David Kosloski, and today we're talking about edge computing and really just the basics of what is the edge. Alongside me today, I've got the Chief Revenue Officer, Ryan McAnlist.
Hey, David.
Hey, thanks for coming.
Thanks for having me.
And also we have Jonny Smith, who is the CEO of SNUC. They're both from SNUC, I guess. I didn't bring up the company that we all wonderfully work for. But Jonny, thanks for being here.
Thanks. Good to have you here.
Yeah, I am happy to be here. Thanks for having me. So I think the first question is truly, let's talk about what exactly is edge computing, and give me the basics of it.
Yeah, I can take that. So there's lots of interpretation of what is edge computing. If you say edge compute, depends who you're talking to and what they will think it is. So they might think it's enterprise edge, they might think it's data center edge, they might think it's something else. But I think what we're talking about is what's at the very edge. So edge computing being where people and things live. So a good example might be my smartwatch. My smartwatch, these things didn't exist not that long ago, and now they give me insightful information and analysis on my activity. They can understand my walking, my heart rate. They can help me play golf better. They do so many things with compute power sitting right here on my wrist. So edge compute is where what we're talking about is where people and things live.
Yeah, that's great. And what outside of, let's use an example here. I like the Apple Watch. What are some benefits, though, I guess, of edge computing versus if that device had to communicate to somewhere else?
Yeah, and I think it does both, right? Mm-hmm. So it communicates with the cloud. So cloud computing obviously has been around for a long time, and it's really given us massive benefits of having huge ability to deliver compute at a great cost. Now, the challenge with the cloud for where people live is that kind of connected device experience. So we're not always connected, and to be able to have the compute power and the analysis available anytime, anywhere, means that we need that compute to live at the edge, not always in the cloud. The two together are very, very complementary.
Sure. What's the benefits of the edge, I guess, and is there another example where the watch is small, right, and it's doing simple calculations, I would assume, versus something more complex like an autonomous vehicle?
Yeah, like years ago there was no need for the edge, but Ryan chatted about his watch there. But if you think of all of the edge devices that exist, whether it's a watch, whether it's stuff in your kitchen, a smart fridge, whether it's a smart TV, the amount of data that is being processed at the edge now is crazy. So even in the simplistic watch, the amount of data that is processing, Ryan chatted there about it makes him a better golfer. I'm not sure there's much could make Ryan a better golfer, but
that's true.
Even in that, the amount of data that it is processing and needs to process right here and right now. You're asking there, what is the benefit? Autonomous vehicles, we're not quite there yet, but we're certainly getting there. Whether that's autonomous vehicle that is on the road or whether that's autonomous vehicles in the air, the amount of data that needs to be processed there. But actually the latency that it takes for that data to be processed in the cloud. Is the cloud irrelevant? No, it's not irrelevant, but I think as technology moves forward and the amount of data that is being processed, it's all about latency. It's all about speed and the speed that it needs to be done in. Now, if you take, we load a web page, 1 or 2 seconds to load a web page, we can probably live with that. Sometimes we get a little frustrated. But in an autonomous vehicle, that changes the whole dynamic.
Yeah.
Where we can't wait milliseconds in autonomous vehicles. Certainly autonomous vehicles that we or our children will be in, we can't wait milliseconds for that data to be processed, sent to the cloud, for it to be given an answer to be sent back to the autonomous vehicle. So, for me, as technology moves and moves more into autonomous vehicles, it's all about latency and speed of that data.
Yeah. So when we're just kind of reiterate, I think what we're saying is that the cloud is essentially this supercomputer that is making decisions based off of what it's seeing, right, from the Internet of Things device. And in this instance, if something is happening, it has to communicate to the cloud. That's taking a lot of time. But on top of that, there are also other benefits, right? Cost savings from a bandwidth perspective. I mean, what other?
Well, as Jonny was saying, like the more that we have analysis and information living at the edge, the more data we create. And the more data we create, the more it costs to transfer that data from point to point. So actually, never mind the latency, but actually the processing of the data to live at the edge, there's a lot of data then. The forecast from smarter people than me is that there's going to be more data at the edge over the next 5 years than there is living in the cloud. And that requires more devices to live at the edge, more compute power to live at the edge, just to process that data and to store it and to manage it. So edge compute is becoming more and more critical compared to what it might have been seen as in years gone by, whereas it's non-essential. So it's not critical hardware for the enterprise. It's not critical hardware for individuals, but it's becoming more and more critical. The other example that I quite like that you were kind of touching on, Jonny, lack of patience as humans is the autonomous drive-through. So, in quick serve restaurants, they're really moving towards how do we automate all these processes? And if somebody drives up and says, "Hey, can I order a burger?" Like in your accent, it's probably going to understand you. In my accent, it might think a little. But if it takes a few seconds, if it's not that natural interaction between machine and human, we're going to know, and we're also going to just think, I don't like that. I'd rather go somewhere else for that human interaction. So that means that edge compute has got to deliver performance, and it's got to have that real experience. Otherwise, we're going to go and do something else.
Yeah. So it saves on bandwidth, right? But it also only sends vital information, correct, to the cloud, because cloud doesn't go away, right?
Correct.
Cloud has to be there, and the cloud can sort of send messages to the edge devices to update maybe the AI or the algorithm machine learning system that's within the edge device, right?
Well, so there's four main reasons why edge compute is critical. So the latency is one of them. Mm-hmm. The availability of the bandwidth. So there's places where it's just not available. Middle of the ocean, middle of a desert, inside a lead room. So there's places where it's just not available. So you need that compute power to live where it's at. When it is available, how available is it? Is it up and down? People live with experiences of the broadband going out, but you rely on it. But if you have to rely on it for critical infrastructure at the edge, that's a problem. And then as we move more and more into a world where security and cybersecurity and physical security is a problem, we're using the edge to deliver security answers, and we need the compute power to live in that space. So those are kind of the four main and critical points why edge computing is important.
Do you think each area or every use case, like when you talk about the four, is there a priority of this is the most important, or is it they're all important but in various sectors or applications?
I think it depends who it is and what the use case is. Like Jonny's example of autonomous driving, latency is the most critical thing there.
For sure.
So, but there's probably other examples.
Yeah, and Ryan touched on QSRs, the autonomous drive-through and QSRs. But if you look at QSR on a whole, the amount of technology that's being used there, whether it's in sensors or cameras, or the autonomous drive-through, every vertical has a different requirement. Security is probably less relevant in QSR, but the amount of data that's being processed, certainly with the amount of cameras that are in QSRs, the amount of sensors and the autonomous drive-through. So
kiosks they're pervasive in QSR now.
Yeah. So to answer your question, all four are critical, but there's probably, depending on the vertical, there's probably three that are more relevant depending on what vertical it is.
Sure. How widely has this been rolled out? Like when we talk about extreme edge, like is it where outside of your Apple Watch, which is a great example in a consumer system, like are businesses adopting extreme edge, and is it a thing that we just are unable to see, that we're unaware of that's happening?
On a technology lifecycle curve of where is edge computing, it's still for most in its infancy. So we're seeing the leading technology adopters across the verticals adopting or having an edge compute strategy in place and executing well against it. I think others are trying to understand what that means and how to do it. So the companies that really can see an opportunity for generating revenue off the back of connected devices and edge compute are adopting that strategy. There are others who are laggards and will always be laggards in waiting for others to prove it. That they're thinking about it, I would say, but it'll happen fast. So over the next 5 years, it's probably a critical time for edge compute.
Do you think there's an alternative?
So I don't see how, especially with AI. AI is just going to flow through society. So I don't see how you can deliver that AI without compute at the edge.
Yeah, it seems. So sometimes I think like we are in that era of the edge, and it has been deployed. Whether people are aware of it or not, it already has been deployed, and they may be aware of it, they may not. Like if you take, buses, for example, the amount of sensors and cameras on a bus now, and people getting on and off a bus, are they automatically thinking, well, there's edge compute here that is processing the reality that I'm getting on and off the bus because the camera's tracking to see how many people are on the bus to make the bus journeys more efficient, the right bus being used in the right journey. So I think, is there an alternative? I don't think there's an alternative, but I think it's being used more widely than people realize. With sensors and data, it just provides companies the ability to be more efficient and drive efficiency by collecting the data they need to understand their business and their business model.
I think, and you're also being tracked.
Yeah. I think too, though, is the size factor, right, is changing, right? These AI models, as they continue to get smaller, et cetera, like the devices will begin to get smaller. And so I think even from the edge perspective, I've heard people explain edge as like a server in a building, and then that server essentially operates all these different devices within the store. However, it's possible that in the future, there will be solutions that are much smaller that can actually be implemented into each of those devices in itself natively, which I think is probably the most exciting part of it, right? Each camera has its own AI model built into it, communicating and processing data versus one centralized location, further making it smaller. So
absolutely, and I think it's that what we talked about earlier, this ecosystem of solutions coming together now, the complementary part of cloud infrastructure and cloud compute, together with advancements in software development, together with the ability to have compute living at the edge. And this ecosystem of being able to manage the devices, being able to virtualize the devices, being able to have the complementary connectivity, this brings exponential possibility in industry as well as for us as individuals.
Right, for sure. So one of the things that I wanted to touch on specifically is that, Ryan, you have a background that is very unique. You were a dairy farmer back in the day. And if I recall, we had a conversation when I was originally interviewing to work with you is around how that process can not only just be automated, but how edge computing sort of plays a part in it. And it was probably the most exciting conversation. And it sounds weird because it's dairy farming, but to me, I was like, this is incredible. And it's exciting. Can you go over first, you have an unconscious bias of like, or a knowledge, of like competence of what you know about dairy farming. Let's explain this process before the edge computing is involved. And then let's talk about what edge computing was able to do for it.
So I was never a dairy farmer. We'll clear that up.
Oh.
My father was a dairy farmer, and I come from generations of dairy farmers in County Armagh in Ireland.
Got it.
And the dairy farm is still there, and it exists now like it's almost like a museum piece compared to what modern dairy farming is. So dairy is very, very important to the world, and what we need from cattle is to produce milk, and that's gone from sitting on a stool with a bucket under a cow hand milking to then industrial revolution and technology being able to do that through a farmer being able to milk multiple cows at once. Sorry, that is the action of putting the suction cups on the udder of the cow. And now we've got a completely automated process in agriculture. So it's that end-to-end management of a dairy farm from birth, how they're managed, how the cattle are managed from birth through their life cycle, the healthcare, and how that automated management of the healthcare for hoof healthcare or any other part of critical healthcare connected to the local veterinaries, right through to automated machines that can milk and manage the milk output, protein output, fat content of the milk, right through connecting that to the logistics of how you get that milk from the farms and the network of farms or the co-ops right through to on the shelves of our supermarkets. So edge computing is living right through that process, and it's fascinating. So can I tell another quick story about that?
Yeah.
So one of our colleagues, a guy called Matt Ford, I think he might be in another episode. I used to work with him when I was in Cisco Systems, and I remember talking to him nearly 15 years ago about, hey, what if we put a router on a cow? On a cow? And he was like, don't be ridiculous. But now, the amount of technology, machine vision, and connectivity that the cattle are even wearing to manage their healthcare, their food, the entire process around a farm is astronomical. So edge computing lives in agriculture and is really driving efficiencies, better for the cattle, and it's also better for the earth, because actually a higher yield output per cow means lower emissions from a herd of cattle. So it's compute is helping all of those things. It's quite hard to connect all those things, but
yeah. But you give an example of how it's being utilized, I guess. Like, what is the system, the process of edge computing being involved in dairy farming today?
Yeah, so I'll give you a quick example. So machine vision. So a camera that might live in the farm, it might be able to identify, okay, what is that cow? What cow number is that I see? How is it walking today compared to how it walked yesterday? I can use local compute together with a large language model that might live in the cloud to understand what is the healthcare of that cow like today compared to yesterday. And if it has a problem, so that camera will do gait analysis. You can see how it's walked yesterday compared to how it walks today. There's great stories of cows that have hoof problems. When they walk past the farmer, they can walk naturally, and they walk around the corner, they start limping again. So they can know this, but they can't do that for a camera.
Right.
So that is that connected device, that camera connected to compute living it with the camera connected to the cloud and the large language model can do analysis on that cattle and have give it a better lifespan, a better, more healthy life while it's existing on the farm.
Yeah. And you're saying that, just to reiterate, the farmer may not necessarily always see the gait issue, even though they have 40 years of experience doing it. The AI model might be able to pick it up a little bit better.
Well, I'm not sure you'll ever meet a farmer who will admit that, because they know farmers are so proud of knowing their livestock and having a great relationship with their livestock, and they do, and they are, but a lot of progressive farmers are adopting technology to help their farm become more efficient. It can generate more cash, but it's also better for for their livestock. And we know farmers on the whole generally really care about their livestock.
The snippet I got is that farmers aren't as good as technology and that they're out of their job. Tech is taking over.
I will get in big trouble with my dad for that.
No, we're putting it out there. It's done.
Thanks.
Yeah. This is great. So are there any other industries that you can think of that benefit from edge technology, just kind of swinging in there? I'm sure they all do, but I mean, is there anything off the top of mind?
Yeah, I've got one.
Okay.
I think where a lot of people are looking for edge compute to interact with us as consumers is in retail. So in that retail experience of, at the minute, a lot of people are buying from Amazon, right? But actually as humans, we like that relationship. So we want to shop local, but sometimes we find it difficult. I think that retail experience is changing, and it's changing fast. So outside of quick serve restaurants, edge compute for an independent retailer or a chain of retailers is having a big impact. I'll give you a few examples. Digital signage used to be outside the realm of cost for most retailers, and now the cost of digital signage is lowering. So these retailers can run special events or discount events on the fly throughout the day, depending on what the weather's like, depending on how many people are in the store. So they can have customizable events connected to door counters, camera counters, queue counters, Wi-Fi accessibility. And it gives us as consumers a different retail experience, which is really exciting. That stock management for, can I get something? If we're looking for something niche, how do we get that locally? That's going to start to help the supply chain analysis and the logistics for accessibility of hard to find items. So for consumers, I think retail is going to have a very, very short-term impact. Edge compute is going to deliver some great impact for how we shop. And it already is. We've mentioned kiosks a number of times, but kiosks and self-checkout, love it or loathe it, will get better. And retail is going to have a great transformation in the next few years because of edge compute.
Awesome. Well, thank you guys so much for taking the time out of your day to talk about the basics of edge computing. And thank you so much for tuning in and listening to the Edge Tech Podcast. Again, I'm David Kosloski. If you like this episode, please like, share, subscribe, or comment. It really helps out the show and helps us produce more content. Thanks so much for listening. Take care.